Next is discrete distributions. Here we will be studying about Bernoulli's and Bernoulli distribution. Here the discrete random variables are used to describe the random phenomena in which only the integer values can occur. Okay. So here we will be discussing in this topic different distributions. Okay. The first one here we are going to discuss is Bernoulli trials and Bernoulli distribution. For Bernoulli trials, a Bernoulli trial is an experiment with result of success or failure. Okay, it will be having whether it is success or fail, two things. Okay, as a result for this Bernoulli trial. Consider an experiment consisting of n trials, each of which can be have a success or a failure. Let xj is equal to 1. If jth experiment is success, if xj is equal to 0, if jth experiment is failure. Okay, Bernoulli trial means you will be having result will be only two things. It can be success or fail. If it is success, xj equal to 1. If it is failure, xj equal to 0. Okay, n Bernoulli trials are called as Bernoulli process. If the trials are independent to each other, each trial has only two outcomes, that is success or failure. Okay, the probability of success remains constant for trial to trial, that is p of x comma x2 comma to xn, that is equal to p1 into x1, p1 of x1 into p2 of x2 to pn of xn. Okay, next pj of xj is equal to pj of xj, that is p xj is equal to 1 to n, whether the j value is 1 to n, and 1 minus p equal to q, xj equal to 0, j equal to 1 to n, otherwise it is 0. Okay, p of xj. This can be written as pj of xj or p of xj. Okay, the xj value is 1, then it is p. P of xj is equal to p. If the xj value is 0, that is failure. That time p of xj is equal to 1 minus p, that we can also say it as q. Q is nothing but 1 minus p. Otherwise it is 0. Okay, this is called Bernoulli distribution. The mean and variance of xj are calculated by using this. Mean E of xj is equal to 0 into q plus 1 into p. That is nothing but mean is E of xj's mean is p. Variance is V of xj equal to 0 square into q plus 1 square into p, that minus p square. That is nothing but variance is V of xj is equal to p into 1 minus p. Okay, that is the variance for Bernoulli distribution. Okay, next we'll see the binomial distribution. The random variable x that denotes number of success in n Bernoulli trials has binomial distribution of p of x. The random variable x that denotes number of successes in n Bernoulli trials has a binomial distribution p of x. So that binomial distribution p of x can be calculated by using this equation. P of x equal to nx into p power x into q power n minus 1, where x equal to 0 to n. Okay, otherwise it is 0. This is the binomial distribution equation, p of x value. Okay, then to solve this, we can write it as q value is 1 minus p. So this can be written as number of successes and number of failures can be written as p power x into q power n minus x. Okay, and nx can be written as this, nx can be written as n factorial divided by x factorial into n minus x factorial. Okay, so we can use this to calculate it. And the mean for this binomial distribution is E of x is equal to n number of p's, that is n into p. Okay, variance for this binomial distribution is V of x equal to PQ plus n number of PQs, P into Q. So the variance is n into P into Q is the variance. Mean is n into P. Okay, using this we have a problem here. Okay, here this is the problem related to this binomial distribution. Okay, here a production process manufactures a computer chip on the average at 2% non-conforming. Okay, and every day a random sample of size 50 is taken from the process. Okay, and if the sample contains more than two non-conforming chips, the process will be stopped. If the sample contains more than two non-conforming chips, then the process will be stopped. Okay, compute the probability that the process is stopped by sampling C.
Yeah.
Okay, here uh, here they have given that the sampling process consists of 50 trials, that is n is equal to 50 Bernoulli trials they have given, and p is equal to 2 by 100, because it is they have given here it is as 2% is non-conforming, average 2% will be non-conforming, so p is equal to 2%, that is 2 by 100, that is p value will be 0.02. Okay, if you know the p, we can calculate the q value, that is nothing but p is nothing but 1 minus q is nothing but 1 minus p, so that is q is equal to 1 minus 0.02, that is 0.98. Okay, let total number of defective chips in the sample is x. Okay, x has a binomial distribution given by p of x. Okay, and the p of x will be calculated in the binomial distribution. P of x will be nx into p power x into q power n minus 1 for x equal to 0 to 50. Here the n value they have given in the question is 50, so x equal to 0 to 50, otherwise it is 0. So we have substituted this x value, n value into this binomial distribution formula. So it is p of x equal to 50x into 0. P value we calculated, that is 0.02 power x, and q value also we came to know, that is 1 minus p, that is 0.98 power 50 minus x for all x equal to 0 to 50, otherwise it is 0. Okay, so it is much easier to compute the right hand side of the following. Okay, identify to compute the probability that more than two non-conforming chips are found in a sample. More than two non-conforming chips are found in a sample. That is that what we need to find here, p of x greater than or equal to 2. More than two non-conforming chips we need to find it. So p of x greater than or equal to greater than 2 can be written as 1 minus p of x less than or equal to 2. Okay, this equation can be written like this. P of x minus x greater than 2 can be written as 1 minus p of x less than or equal to 2. Okay, we know how to find it, x less than or equal to 2. If p of x less than or equal to 2 is nothing but x equal to 0 sigma 2 50x into 0.02 power x into 0.98 50 minus x. Okay, here the x value is 0 to 2. Okay, so wherever x value we substitute it 0 once, x value we substitute it as 1, and x value we substitute it as 2. Okay, so this summation will have three terms. One is x equal to 0, x equal to 1, and x equal to 2. That is, if x equal to 0, then we'll get 0.98 power 50. If x equal to 1, that is 50 into 0.02 into 0.98 power 49. if x equal to 1. If x equal to 2, it is 1225 into 0.02 power 2 into 0.98 power 48. If you calculate this, we will get 0.92. Okay, that is P of x less than or equal to 2 value. Okay, if you know this x less than or equal to 2 value, we can easily find P of x greater than 2. P of x greater than 2 can be written as 1 minus P of x less than or equal to 2. That is 1 minus 0.92. We will get x greater than 2 will be 0.08. Okay, and mean will be E of x equal to n into p. Mean calculation formula is np, right? N value is, we know it is 50. P value we have calculated, that is 0.02. So the mean is 50 into 0.02, that is 1. Okay, variance formula is V of x equal to n into p cube. N is 50, p value is 0.02, q value is 0.98. So if you multiply this, we'll get variance, that is 0.98. Okay, like this we need to solve the problem. Next one is geometric and negative binomial distribution. Whatever we have discussed now is positive binomial distribution. Now we'll see geometric and distribution and negative binomial distribution. In geometric distribution, the geometric distribution is related to a sequence of Bernoulli trials. Okay, let x equal to number of trials to achieve the first success. Okay, and x has the geometric distribution given by P of x equal to q power x minus 1 into p for x equal to 1 to n. And otherwise, it is 0. Okay, here the justification they have given is like this: x minus 1 failures followed by 1 success. Okay, and P of failures followed by 1 success. Okay, this is x minus 1 failures will followed by 1 success. Okay, that can be written as q power x minus 1 into p. Okay, so the mean is e of x equal to 1 by p, and here the variance for this geometric distribution variance is q by p square is the variance. Okay, remember these formulas. Next is negative binomial distribution. It is a distribution of number of trials until kth success for k equal to 1 to infinity. If y has the negative binomial distribution with the parameters p and k, its distribution will be written like this: p of y is equal to y minus 1 k minus 1 into q power y minus k into p power k. That is y equal to k comma k plus 1, k plus 2, k plus 3 until infinity. Okay, y value. Otherwise, it is 0 here. Okay, here the mean value for the negative binomial distribution is E of y is equal to k by p, and variance is V of x equal to k into q divided by p square is the variance for negative binomial distribution. And using this negative binomial distribution also, we have a formula. Just need to substitute these values in this formula, we will get the solution. Okay, next distribution is Poisson distribution. It describes many random process quite well and is mathematically quite simple. Okay, Poisson distribution is very, very important. Usually it will be asked in the VTU exams. Okay, explain Poisson distribution with its mean and variance, like that it will be asked in the VTU exams. Okay, here the Poisson distribution probability is, the Poisson probability mass function is, okay, p of x equal to e power minus alpha into alpha power x divided by x factorial, where x equal to 0 to infinity, 0, 1 and infinity. Otherwise it is 0. Okay, where the alpha value will be greater than or equal to 0. Mean is equal to, for Poisson distribution, mean is E of x is equal to alpha. Okay, and variance is V of x equal to alpha, where in Poisson distribution mean is always equal to variance. Okay, and cumulative distribution function CDF. CDF for this Poisson distribution is f of x equal to I equal to 0 to x sigma e power minus alpha into alpha power I divided by I factorial is CDF for the Poisson distribution. And here we have a small problem related to Poisson distribution. Okay, we'll just see this. A computer repair person beep each time there is a call for service. Okay, the number of beeps per hour is known to occur in accordance with the Poisson distribution with the mean of alpha is equal to 2 per hour. Okay, find the probability of 3 beeps in next hour. Okay, what is the probability of getting 3 beeps in the next hour? We need to find it. And also find the probability of 2 or more beeps in 1 hour period. Okay, this is example problem for Poisson distribution. Here we have given the alpha value is given as 2 and x value is given as 3, and probability of 3 beeps in the next hour we need to find. For that, formula is P of 3 is equal to e power minus alpha, that is alpha value is 2, so e power minus 2 into uh, alpha power x. Alpha is 2, x value is 3 divided by x factorial. X factorial is nothing but 3 factorial. We will, if you solve this, we will get 0.18. And the probability of 2 or more beeps in 1 hour period we need to calculate. That is P of 2 or more. How can we write this 2 or more? That 2 or more can be written as 1 minus P of 0 minus P of 1. Okay, that will get it 2 or more value. So 1 minus P of 0 minus P of 1 is nothing but F of 1. Okay, so F of 1 value we got it as 0.406. Okay, by using this formula. That is F of x can be calculated as I equal to 0 sigma x e power minus alpha into alpha power I divided by I factorial. If you solve it, F of x value will get it as 0.406. So for the 2 or more beeps, the value is 0.594. Okay, these are substitution kind of problems. Next one is continuous distribution, where the continuous random variables can be used to describe the random phenomena in which the variable of interest can taken on any value in some trial is continuous random variable. The continuous random variables can be used to describe the random phenomena in which the variable of interest can take on any value in some interval. Okay, here we have the uniform distribution, that is a random variable x is uniformly distributed on the interval a comma b if its PDF and CDFs are given like this. Okay, PDF will be f of x equal to 1 by b minus a for all a less than or equal to x less than or equal to b, otherwise 0. Okay, a CDF will be given as f of x equal to 0 for x is less than a, x minus a divided by b minus a for a less than or equal to x less than b, otherwise it is 1 for x greater than b, greater than or equal to b, it is 1, f of x equal to 1. Okay, these are the PDF and CDS for the uniform distribution. Okay, here in uniform distribution, P of x1 is less than x2 is equal to f of x2 minus f of x1. That is upper limit minus lower limit. Okay, that value we will get it as x2 minus x1 divided by b minus a. Okay, here the mean for the uniform distribution is E of x equal to a plus b by 2, and variance for uniform distribution is b minus a whole square divided by 12 is the variance for uniform distribution. Okay, and here we have one small problem related to uniform distribution. Next, we have exponential distribution. In exponential distribution, a random variable x is said to be exponentially distributed with the parameter lambda is greater than 0. Okay, if its PDF and CDF is given like this, PDF is f of x is equal to lambda into e power minus lambda x, that is for x is greater than or equal to 0. Okay, otherwise f of x is equal to 0. Okay, CDF is given like this, capital F of x is equal to 0 for x is less than 0. Okay, if x is greater than or equal to 0, then f of x is 0 to x lambda e power minus lambda t into dt. This can be written as, we have already seen this formula. If the expression is in this way, we can write it as 1 minus e power minus lambda x. Okay. Mean is e of x is equal to 1 divided by lambda, whereas variance is v of x equal to 1 by lambda square is the variance for exponential distribution. Okay, this is also important. Usually it will be asked in video exams. Explain exponential distribution like that questions. That time you need to write the PDF, CDF, mean and variance. And the exponential distribution is used to model the completely random interarrival times. Okay, random interarrival times we can model by using the exponential distribution, and highly variable service times and lifetime of a component that fails instantaneously, where we in these cases we will be using exponential distribution will be used for modeling. Okay, so here lambda is a interpreted as a rate here. Okay, it can be like arrivals per hour, service per minute, failure rate will be represented as lambda here. Okay, and memory less property of a exponential distribution random variable states that the future value of exponentially distributed values are not affected by the past value. The future values of exponentially distributed values are not affected by past values. This can be in other words like we know nothing about the future values of random variables given full history of the past variables. That can be written like this: p of x greater than s plus t, x greater than s is given like this: p of x greater than s plus t divided by p of x greater than s. So that can be written as e power minus lambda into s plus t divided by e power minus lambda s. Okay, that is nothing but e power minus lambda t. Okay, so p of x greater than s plus t or x greater than s is equal to p of x greater than t. Okay, here we have a small problem related to that uh, exponential distribution. Next another distribution here is gamma distribution. It's a function used in defining a gamma distribution is gamma function. Okay, function used in gamma distribution is gamma function, which is defined for all beta values where beta is greater than 0 and tau of beta is equal to 0 to infinity x power beta minus 1 and e power minus x dx for beta is greater than or equal to greater than 0. Okay, tau of beta is equal to beta minus 1 into tau of beta minus 1. Okay, that's the gamma function. Okay, if beta is an integer, then by using tau of 1 is equal to 1 and applying the equation tau of beta is equal to beta minus 1 factorial. Okay. The random variable x is gamma distribution with the parameters are beta and theta. If its PDF is given by f of x is equal to beta into theta divided by tau of beta into theta into x whole power beta minus 1 and e power minus beta into theta into x for x is greater than 0. Otherwise, it is f of x is 0. This is for gamma distribution. Okay. And here the CDF for the gamma distribution is f of x is equal to 1 minus x2 minus infinity beta into theta divided by tau into beta into theta into t power beta minus 1 e power minus beta into theta into t dt for x is greater than 0. Otherwise, f of x is equal to 0 for x is less than or equal to 0. Okay. Beta is called shape parameter. Here the theta is called scale parameter. Okay. Beta is a shape parameter, theta is the scale parameter. Mean of this gamma distribution is E of x is equal to 1 divided by theta. Variance is V of x equal to 1 divided by beta into theta square. Okay. When beta is an integer, the gamma distribution is related to exponential distribution, whereas PDF of it is g of xj is equal to beta into theta into e power minus beta theta xj for all x greater than or equal to 0. Otherwise, g of xj is equal to 0. Okay, this is about gamma distribution. Next one is Erlang distribution. Here in Erlang distribution, when beta is equal to k, an integer, we refer to gamma distribution as a Erlang distribution. Okay, when beta is equal to k and it is an integer, we refer the gamma distribution as a Erlang distribution when the beta is equal to k and it is an integer. So that time the E of x mean value will be calculated like this. E of x is equal to E of x1 plus E of x2 to E of xk. That can be written as E of x is equal to k into 1 by k theta. That can be written as 1 by theta. Okay, mean for the Erlang distribution is 1 by theta. Variance is v of x is equal to v of x1 plus v of x2 plus v of x3 plus until v of xk. This can be written as k into 1 by k theta whole square. So that is equal to 1 by k theta square. Okay. When beta equal to k and it is a positive integer, the CDF for this Erlang distribution is f of x is equal to 1 minus sigma I equal to 0 to k minus 1. That is e power minus k into theta into x into k theta x power I divided by I factorial for x is greater than 0. Okay. Otherwise, f of x is equal to 0. Okay. That is for x is less than or equal to 0 means f of x is equal to 0 for Erlang distribution. Understood this? For every distribution, we need to remember that CDF, PDF and variance formula and mean formula. Mean, variance, if there is standard deviation formula, PDF and CDF. Okay, next one is normal distribution. It's a random variable x has the normal distribution with the mean value mu and variance is standard deviation square if it's given by f of x equal to sigma square root of pi exponential of minus 1 by 2 x minus mu divided by sigma whole square. Okay, that is for x equal to less than infinity, so minus infinity less than x less than positive infinity. Okay, here the notation is x equal to n when it is mu comma sigma square. Okay, random variable x is normally distributed with the mean mu and variance sigma square. And special properties of normal distribution is limit x tends to minus infinity, f of x is equal to 0, and limit x tends to positive infinity, okay, plus infinity, f of x equal to 0. The values of f of x approaches to 0 as x tends to the infinity. Okay, and f of mu minus x is equal to f of mu plus x. This is the PDF is semantic about mu. Max value of PDF occurs at x is equal to mu. The mean and mode are equal here. Okay, and the CDF is given like this: f of x is equal to p of x less than or equal to x, that equal to negative infinity to x 1 divided by sigma square root of 2 pi into exponential of minus 1 by 2 t minus mu by sigma whole square into dt. That is the CDF. Okay, that is for normal distribution CDF. And here it is given how CDF is evaluated. And this is a formula related to that normal distribution. Next, we have another distribution called variable distribution. Variable distribution, the random variable x has a variable distribution if its PDF is f of x equal to beta by alpha into x minus b divided by alpha whole power beta minus 1 into exponential of minus x minus b divided by alpha whole power beta for x is greater than or equal to v. Otherwise, it is 0. Here, the v is nothing but local parameter, beta is scale parameter, alpha is shape parameter in variable distribution. When v equal to 0 and beta equal to 1, f of x equal to 1 by alpha into e power minus x by alpha for x is greater than or equal to 0. Otherwise, f of x equal to 0. Okay, here the mean e of x will be calculated by using this equation. E of x equal to v plus alpha into tau of 1 by beta plus 1. V of x can be, variance can be calculated like this: V of x equal to alpha square into tau of 2 by beta plus 1 minus tau of 1 by beta plus 1 whole square. You will get the variance. Okay, and CDF is given like this: CDF is f of x equal to 0 if x is less than v. Okay, if x is greater than or equal to v, then f of x is 1 minus exponential of minus x minus v divided by alpha whole power beta. That is CDF. After this, we have, after variable distribution, we have triangular distribution. In triangular distribution, a random variable x has a triangle distribution. Its PDF is given like this: f of x equal to 2 into x minus a divided by b minus a into c minus a. For x value will be within the range of a less than or equal to x less than or equal to b. Okay, if f of x will be 2 into c minus x divided by c minus b into c minus a, when x value lies between b less than x less than or equal to c. Okay, otherwise f of x will be 0. Okay, next mean is e of x equal to a plus b plus c divided by 3. Mod is b equal to 3 into e of x minus a plus c is the mod. And CDF for this is triangular distribution is f of x equal to 0 if x is less than or equal to a. Okay, and f of x is x minus a whole square divided by b minus a into c minus a. That is for a less than x less than or equal to b. Okay, and f of x equal to 1 minus c minus x whole square divided by c minus b into c minus a for b less than x less than or equal to C. F of x equal to 1 if x is greater than C. Okay, that is the CDF for triangular distribution. Next one is log normal distribution. Okay, a random variable x has log normal distribution if its PDF is f of x equal to 1 divided by square root of 2 pi into sigma x. Exponential of minus log n x minus mu whole square divided by 2 sigma square. That is for x is greater than 0. Okay, otherwise f of x equal to 0. Where sigma square is greater than 0, the mean is E of x is equal to e power mu plus sigma square by 2. Whereas variance is V of x equal to e power 2 mu plus sigma square into e power sigma square minus 1. That is the variance. Okay. Mu value will be calculated like this. Log of mu L square divided by square root of mu L square plus sigma L square. Okay. Sigma square can be calculated as sigma square equal to log of mu L square plus sigma L square divided by mu L square. Okay, this is the way we can find the mean, variance and standard deviation for log normal distribution. Okay, next one we have is beta distribution. For beta distribution also we need to remember the PDF, CDF, mean, variance. Okay, beta distribution, a random variable x is a beta distribution with the parameters beta 1 is greater than 0, beta 2 is greater than 0. Then if it is PDF is given like this. F of x equal to x power beta 1 minus 1, 1 minus x, beta 2 minus 1 divided by b into beta 1 comma beta 2. Okay, this is for 0 less than x less than 1. Otherwise, f of x equal to 0. Okay, y equal to a plus b minus a into x, where mean and variance of y is given by in the range of a comma b range, that is a plus b minus a into beta 1 divided by beta 1 plus beta 2. That is the mean. Variance is b minus a whole square into beta 1 into beta 2 divided by beta 1 plus beta 2 whole square into beta 1 plus beta 2 plus 1. That is variance. Okay, variance for beta distribution. Next we have the Poisson process. That is n of t is counting function that represents the number of event occurred in the range of 0 comma t. A counting process n of t is t greater than or equal to 0 is a Poisson process with mean rate is lambda. Okay, if arrival occurs at a time and n of t comma t greater than or equal to 0 has a stationary increment. Okay, then the distribution of number of arrivals between the t and ts depends on only the length of the interval s, not on the starting point t. So the arrivals are completely at random without rush or slack periods. Okay, next point here is n of t comma t greater than or equal to 0 has independent increments. The number of arrivals during the non-overlapping time intervals are independent random variables. So the large or small number of arrivals in the time interval has no effect on number of arrivals in subsequent time intervals. Further arrivals are occur completely at random. Okay, independent of number of arrivals in past time intervals. Okay, this is Poisson process. And we'll see the Poisson process mean and variance. If the arrivals occur according to the Poisson process, it can be shown as n of t is equal to n is given by p of n of t is equal to n, that is e power minus lambda t into lambda t power n divided by n factorial for t greater than or equal to 0 and n equal to 0 to infinity, where the mean and variance is e of n of t is equal to alpha, that equal to lambda t, that equal to variance v of n of t. Okay, v of n of t is equal to, here the mean and variance are same. Mean is equal to variance. Next we have here interval times, probability of Poisson process, that is splitting and pooling. Splitting is nothing but splitting it equation. Pooling is pooling it together as single thing is pooling. Next one is non-stationary Poisson process, empirical distribution. Okay, these are the things we'll be covering here in this statistical modules in simulation. With this, first part of second module is completed.